In this video we are looking at correlation and regression. Correlation and regression are what we use to examine the relationship between two metric variables. In this case we are looking at weekly salary and years of experience. Correlation tells me about the strength of a linear relationship between the two variables. The closer to negative one or the closer to positive one, the stronger the relationship. Where a negative correlation tells me that as one variable goes up, the other one tends to go down, and a positive correlation tells me that as one variable goes up, the other one also tends to go up. From this table we can see the correlation for these variables is 0.652. We would consider this to be a moderate strength correlation. The figure under it is the p-value. The p-value is testing to tell me whether, based on the sample correlation from our sample data, we believe that there is actually a non-zero population correlation. So if we have a p-value less than 0.05, we're saying yes, this is indicating that not only are we seeing correlation in our sample, we would expect that to carry over to our population. Regression is used to create a linear relationship and a linear equation between two metric variables. In this case we have a more clear-cut independent variable and dependent variable. For this example we're using years of experience as a way of predicting weekly salary. On our regression table we have a figure which is our constant or our intercept if we were drawing a graph of the straight line equation, and we have a slope. So the slope tells me how much of an increase in weekly salary we would expect to see for a 1 unit, in this case 1 year of additional experience. So if we were going to graph our line, this would be the slope of our line. We can use these two values to create an equation we call a regression equation. Our regression equation can be used to predict weekly salary for a particular value of years of experience. The table also gives us a p-value for the slope. P-value less than 0.05 is telling me that I think in fact this slope would be represented in the population, so this variable is a significant predictor. So our p-value here, which is very, very small, we can see it rounds to 0, so less than 0.001, is telling me that years of experience is in fact a significant predictor of weekly salary. Our final columns give me a confidence interval for the slope. So whilst the slope of my data in my sample is 28, I would expect that in fact for the population the slope is somewhere between 15 and 40.